exploded. Sun is not going to end as a pulsar. Pulsars are very dense, and they're made of neutrons. In fact, they're neutron stars. They're very, very dense. They're about a dozen miles across, and they have the mass of the entire sun crammed into those dozen miles. You saw the sun and all of Earth? You remember that? Now you take the sun and cram it into a dozen-mile sphere, you get a neutron star. Okay.
Wow.
Now, how dense is a neutron star? That's pretty dense. Let's do it by mass per thimble. Okay? Do people still know what a thimble is? Yeah, we used to sew our own clothes here, and then now they're like made elsewhere.
Oh yeah.
It's a different marketplace of the world. Anyhow, thimbles so you don't prick your finger with your needle. All right, so mass per thimble. The sun will end as what we call a white dwarf, not a neutron star. So this is not so bad. But still, a white dwarf will cram 1 ton of material into a thimble. I thought I'd get a stronger reaction. No, too late. I'll give you another chance, okay? So the sun will end as a white dwarf, which is also very dense matter. So how dense would that be? It would cram a ton of material into a thimble. I knew you'd feel that way. Yeah, that's dense. But a neutron star, 100 million tons. There you go. That is 20 million elephants. You just sort of cram them into the thimble, one after another. Then you get the density of a neutron star. Well, when they collide, they create quite a spectacle. When 2 black holes collide, there's no light in the beginning, middle, or end of that. But 2 neutron stars, that's a spectacle. You can alert the world's telescopes for that. And so it not only gives you gravitational waves, it gives you energy in all wavelengths of light that we have other telescopes to show. And so here's an animation of that. These are 2 neutron stars about to dance. The orbits are unstable, which is why they come closer and closer to each other. And this is a visible phenomenon with our telescopes. And here they go. It's radiating gravitational waves right there, and then the visible light, as well as X-rays and gamma rays. Quite the spectacle. And if you run the math on it and the physics, the nuclear physics, what you find is that all manner of rare elements are created in that explosion. Gold, platinum, selenium, these are rare earth elements, neodymium. We think colliding pulsars might be the primary source of gold in the universe. So then I thought, what's the price of gold? I checked, a week ago, $2,936.39 an ounce. Yeah, no, that's expensive stuff. So given how much gold is produced in colliding pulsars, I calculated how much that's worth. Okay, so here it is. Okay, let's figure out what this number is. So, like the third set of zeros, that's millions, then billions, then trillions. What's next? Quadrillion. Next. Quintillion, sextillion, septillion, octillion, nontillion. $33 nontillion worth of gold. So, that is slightly more money than Elon Musk has. Are there any economists, professional economists in the audience? What happens if you bring all that gold to Earth?
Inflation.
Yeah, it's worth 0, okay? 0. Pulsar collision. Let's keep going. Galaxy collisions, these are my favorite
One of the
of them all.
massive
We finally, when computing power got good enough, we could simulate huge spiral galaxies in collision. What makes it difficult is